So we already talked about shift, stretch, compress. Now we're going to learn how to graph functions using reflections. So there are two different kinds of reflection. One is reflection about the x-axis. The other one is reflection about the y-axis. All right. So when is reflection about the x-axis? When is reflection about the y-axis? The rule is this, okay? If f of x or y, okay, multiplied by -1, and then is reflection about x-axis. Okay, if replace x by -x, and then is reflection about y-axis. Okay, why? Let's graph and then you will see why. So rectangular coordinate system, right? F of x, which is y, when y replaced by when y multiplied by -1, okay, that's -y, right? That's why those two are the corresponding point, right? So we can see that's reflection about x-axis, isn't it? Okay, when replace x by -x, and then is reflection about y-axis. Okay, so from graph point of view, that makes sense, right? So when is y times -1? When is x replace x by -x? Let's look at the example. So we want to graph function f of x equals -x squared, and then find the domain and the range of the function. So first we need to find a key function from library, which is square function, right? Square function's graph is parabola, and then parabola is open upward, and the vertex is right at origin, 0, 0. So we want to get a graph of f of x equals -x squared, right? -x squared. So that's this square function multiplied by -1, right? That's why y times -1, right? Or f of x times -1. Okay? So f of x equals f of x times -1, that's y times -1. Same, right? F of x times -1, y times -1, that's the same. So that's reflection about x-axis. And then just do the mirror image, okay, about x. Okay, that's the graph we're going to get. This is f of x equals x squared, and then this one is f of x equals -x squared. Reflection about x-axis. Domain and range, since this is a y change, x remain the same, right? So domain, it will be all real numbers, right? Range, original square function is 0 to positive infinity, right? Multiplied by -1, that's -infinity to 0. You can tell from the graph also, right? The highest value of the y is 0. Lowest value is -infinity. And then you can see that from the point, okay, every x coordinates remain the same, and then y multiply by -1, right? X remain the same, y times -1, and then every point is like that. Okay, that's the better graph. Reflection about x-axis 1, y times -1. So here's a summary. When right side of the function f of x is multiplied by -1, the graph of a new function y equals -f of x is the reflection about x-axis of the graph of the function y equals f of x. So if you know key function's graph, and then if key function multiplied by -1, you can use reflection about x-axis to get a graph of new function. All right. So what about replace x by negative x. Okay, this is inside the function, right? Earlier is outside function multiplied by -1. And then what if replace x by negative x? Or x times -1, basically, right? And then this is the time reflection about the y-axis. Okay? So we can identify the key function from library, which is square root function. Okay, square root function is the graph like that. Okay, and then reflection about y-axis, the graph should be like that. Okay, my hand graph is not accurate. Okay, but you see the meaning. Just do the mirror image about the y-axis. Okay, it should be look more like that. Okay, sorry. Domain and range will remain the same, right? Because this is x change. So range will be the same as square root function, which is from 0 to positive infinity. But domain, x change, domain will be the multiplied by -1, right? Domain is supposed to be 0 to positive infinity. Now it's negative infinity to 0. Infinity always open, 0 is a close, because x can equal to 0. Okay, that's the reflection about x-axis. This is the more accurate graph. And then the rule is when the graph of the function y equals f of x is known, and then the graph of the new function y equals f of negative x is the reflection about the y-axis of the graph of the function y equals f of x.